Hello and welcome to the SQL Server DBA course by MindMajix. In today's data-driven world, databases are the backbone of every organization, and managing them efficiently is mission critical. That's where SQL Server Database Administrator comes in. SQL Server is one of the most widely used relational database management systems in enterprises worldwide. Whether it's backing up critical data, optimizing performance, or securing sensitive information, SQL Server DBA ensures that the database environment is stable, secure, and high-performing at all the times. In this course, we will cover from SQL Server fundamentals to advanced administrations, including installation, configuration, backup, performance tuning, disaster recovery strategies, and more. According to the LinkedIn and Naukri, there are many companies hiring for SQL Server DBAs. On an average, SQL Server DBA professionals earn between 5 to 18 lakh rupees per annum in India, depending on experience. Companies like Infosys, TCS, Cognizant, Wipro rely on SQL Server DBAs to manage complex data infrastructures. And if you want to learn SQL Server course with certification, then check out our course where we will cover latest industry curriculum, hands-on projects, labs, mock interviews, and more. Before moving ahead, I want you guys to like, share, and subscribe to our channel so you never miss any tutorials and courses from us. So let's get started with our full course.
So let's start like what is SQL Server? So SQL Server is RDBMS. It is Relational Database Management System. So DBMS is the concept for storing the data in the databases. And there are different concepts of database management system also. And RDBMS is one of the concepts. So SQL Server is an relational database management system where data is stored in the databases. So here, this is one of the database, and each database can have multiple tables, and data will be stored in the tables in the form of rows and columns. So here we can see this table has 16 rows, and this is stored in the form of these many columns. There are 4 columns and 16 rows. So in SQL Server, data will be stored in the form of rows and columns in a table, and all these tables are grouped together inside a database. So for ease of maintenance, we create multiple databases, and all the tables related to certain application or certain department, we'll be storing it in different databases. So basically, the SQL Server data is stored in tables, and these tables are stored in the databases. In DBMS, data is stored in databases, and database is collection of data that is logically grouped together. We have seen in the tables the data is logically grouped in the form of rows and columns. And the DBMS has 5 components. So it requires hardware to store the data, and it requires a software application that enables us to store the data in the hardware. And we have the data that is actually stored, and this data will be accessed by the users, and they access data in the through stored procedures or SQL queries. So DBMS is a combination of these 5 components. So using DBMS, we can define a database, create and maintain the databases. So we create a database, we store data in it, and we retrieve the data. So the basic objective of database management system is to store and retrieve data. And there can be multiple users connect to the databases at the same time, and we can control the access of the users on the database as well. So some users, they can make modification on the database, and we can restrict some users only to read data from the database. And there are different other ways to control access. We will go in detail. So these are the components of DBMS we have discussed now: hardware, software, data, users, and procedures. So procedures are set of rules that is used to handle the database management system. The users interact with the database management system through procedures. It can be a stored procedure or a queries. So this is the basic architecture of database management system. So hardware, where actual data is being stored. So it is physically stored in some software hardware like disks or tapes or external storages. And there are three levels before user view. So there is an internal level, conceptual level, and external level. For the user to connect and to store and retrieve data, it has to pass through all these three levels. So internal level, it determines where data is actually stored in the storage device. So this will let us know in which drive the data is being stored. And at conceptual level, so this is at database, from the database level, that is from the SQL Server level, we'll be able to see where the logic, where uh, data is stored logically. So logical view of data is the viewing the data in the form of tables. But while it is being stored internally, that is inside the disks, it is not stored in the form of tables, but which displays to us is in the form of tables. But it is in a different way that is stored in the disks or in the storages. So we'll discuss how it is stored as well. So external level interacts directly with the user. So this is how we interact with the database management system to access the data. So these are the three levels of architecture for accessing the data by users that is stored in the databases. And there are different database models. So database models has evolved over the years, and it has evolved in a fine-grained manner where we can access the data very easily and we can store data very easily. So there are previous models like hierarchical model, network model, and the most advanced model is the relational model for storing the data. So it is a model how to store the data and how to create the relationships between the data so that we can access the data easily. So in hierarchical model, data is stored in the form of inverted tree structure, where the table information is all linked together in the form of inverted B tree structure. And network model, so each table is connected to each other tables in this model. So we are not going to use these two models now, hierarchical and network. We are going to work on relational model. So in relational model, data is stored in the form of rows and columns. So where this rows and column information is stored in a tables. So the data is basically stored in tables. So inside tables, it has number of columns and number of rows to store data. And the example for relational models is MS SQL Server, Oracle, and we have DB2. So these are all the relational database models. Uh, these are all the databases that is based on RDBMS. So in RDBMS, the data is stored in two-dimensional tables. That is, one dimension is row and the other dimension is columns. And all these columns, we call it as attributes. That is the property of that particular value. So here number, that is, it can be a roll number or employee number, name, and unit. So we call these rows as tuples and the columns as attributes in this relation. And we can perform all these type of operations on the relations. Relations is a table here. So we can perform all these type of operations. We can insert new data, delete the data from the table, or make modification to the existing information or existing data. And we can just read the data by using select and project statements. And we can extract information from more than one table by using join, union, intersection, and difference. So these are all the operations that can be performed on the table. So this is an example for insert operation. So a table has 4 rows here. We can include an additional row by using an insert statement. And we can delete a row from the existing table. So here we had 5 rows. By deleting one row, now the table is having 4 rows. And we can make modification to the existing table here. So it is the same 5 rows. Here also it is the same 5 rows. So here the existing values is modified here. So this is the modification. In the networking it was 5. We can change it to 6. I'm just giving a simple examples here. And the select statement is to read the information from the existing table. So it is not going to make any modification. A table may have some hundreds and thousands of rows, and if we want to view the data based on certain condition, we can use a select statement, and you can use where condition to retrieve the information and read it through select statement. And to perform all these tasks, so we have seen insert, update, delete, select. So to perform all these things, so we have to know the language to interact with the SQL server, and the language is the structured query language. So we interact with the SQL server engine through SQL queries. So it is structured query language, and there are different queries that we can use in the structured query language to interact with the SQL server. So I'll just give a simple statement. To extract information from this table, I can just use a simple query here. Select star from table. So this will retrieve all the column and row information from this table and display as a result here. So if you want to get the information of other table, we can just drag and drop the table name here. So these are all the rows and columns in this table. So able to get the idea, Praveen. So I'll get some more topics related to DBMS, but in today's class we'll discuss the responsibilities of database administrator. So let's discuss about the responsibilities of database administrator. So as a database administrator, we'll be having some responsibilities which will, all those tasks should be taken care by us. So it starts with software installation and maintenance. And even before the software installation, looking after the prerequisites for setting up the SQL server is also responsibility of database administrator. So as we discussed, SQL server is a application that will be installed in some of the hosts. So it can be a Windows host or a Linux host also. So in that we are going to install a SQL server software, and the installation of the SQL Server software and maintenance of it is one of the major responsibilities of database administrator. So we have to set up the hardware, and we have to deploy the operating system for the database server also. So usually these tasks will be taken care by Windows team. After that, we have to get the required SQL Server software, and we have to install in the OS. After installing the SQL Server, we'll be creating a databases, and the databases will be used by the applications. So there can be different applications that can store their data in the databases, and as the business grows, the size of the data that is stored in the databases also grows. So basically we'll be handling databases of very large size. So the size of databases can grow to terabytes also. The database administrator should have enough monitoring and performance tuning skills to handle very large size databases. And backup and recovery. So as we discussed, we'll be storing a critical data for the organizations in the databases, and we should maintain the backup of the databases in case if there is any disasters or unwanted things happening on the database. We should be able to recover the database from the backups. So strategizing the backups and recovering the databases from the backups in case of any disaster is one of the major responsibility of the database administrator. And security, so we are going to deal with the critical data. And this critical data should not be accessible to all the users, and we have to protect our data in such a way that there is minimum risks and attacks on our data. And there are different security concepts available in SQL Server to maintain the security of data. So the database administrator should be aware and should be knowledgeable on all the security concepts to provide a maximum security to the data. And we maintain security by creating the users and providing the permissions. And we call them as authentication, authorization, and auditing. So creating a users is authentication, and providing them the required permissions to access the data is authorization. And after providing the required permissions, we have to monitor the access of the users in the server, and we can do that by using auditing. So authentication, authorization, and auditing is also the responsibility of database administrator. And capacity planning. So initially we'll create a database with very small sizes, and also we'll set up infrastructure for the database with a limited features, like it can be start from less RAM, and the number of CPUs that we use, it all will be the less. So the resources that we use for our database will be less initially, but as the size of the database grows, the resource utilization will also be growing. So the database administrator should proactively monitor the database growth and set the capacity planning. So we should ensure the services should not get stopped due to the resource crunch. So we call it as a capacity planning. So proactively provisioning the resources in such a way that it doesn't cause interruption to the services. So for example, we have set up a database, a disk space of 10 GB for a database. And if the database is growing beyond 10 GB, so there should be enough disk space for the database to grow. So we have to provision some 100 GB or 200 GB depending on the database growth rate. So database administrator should monitor the growth of the data as well as the resource utilization, and based on that we have to proactively provision the resources accordingly. And performance monitoring. So setting up of SQL Server, by setting up of SQL Server, the responsibility of not a database administrator is not going to end. So we have to keep on monitoring the performance of SQL Server and on regular basis, and if there is any issues or any bottlenecks found, we have to act on it and we have to resolve the issues immediately so that applications can access the database without any issues. And database tuning. So on finding the issues or bottlenecks in the performance of SQL Server, we have to fine tune them, so to make sure to get the optimal performance from the SQL Server database engine. So the tuning can happen on the query level or at the hardware and software levels also by making the configuration changes. And troubleshooting. So even though we have been monitoring the SQL Server, there is possibility of issues here and there, and database administrator should have enough skills to find out the exact reason and troubleshoot it before the situation becomes worse. So these are all the responsibilities of database administrator. So it starts from installing the SQL Server, creating the databases, provisioning permissions to the user on the databases, and setting up a capacity planning, and monitoring, tuning, and troubleshooting. So these are all the major responsibilities of database administrator. Database is a concept. In the database, this SQL Server, Oracle, these are all different products of the databases, different database products there. So in a common database administration is same for all the products. So SQL Server is one of the product which we are going to learn now, Microsoft SQL Server. So it is for the product from Microsoft, so which we are going to learn. So in database management system, the data is a basic concept. So we are going to handle the data by using a management system which is stored in a database. So what is data? So data is facts or figures. So it is basically some information we are going to store. Can be any information that we are going to store in the computer. We call it as a data. And database, it is collection of interrelated data. So we can have the information about all particular department or particular application stored in a database. And in the database, the data is stored in the form of tables, views, schemas, and reports. So in SQL Server, data is stored in the form of tables and views. And in some other databases, it can be stored in the form of reports also. And database management system, it is a collection of data and management system. And management system is a set of programs. So we are handling the data through set of programs with a basic objective of storing and retrieving the data. So either we store the data or we read the data that is already stored. And DBMS, it is collection of interrelated data, and we use the database management system to access the data in a easy and efficient. So using the DBMS, we can perform all these operations like data definition, data updation, retrieval, and user administration. That is creating a tables and storing the data or update the data that is already up, and read the data using select operation, and user administration to control the access of users on the critical data. So there are different ways of storing data in the computer. So the basic way of storing the data is a file system. So file system is storing the files directly on the hard disk, like creating a text file. So it will be created in some storage, and which we can access from the SQL server, not from the SQL server, from our computer. We can access the file system files. And the issues with the file system is, for example, if you are storing data in the text file, so there can be a redundant data. So the data that is already present once, we may have to use it again and again, and data is not in a consistent manner. So for example, so all this table data, if you are going to store in notepad or a text file, it is going to be difficult to handle. And if you want to read the information in that from the text file, so it is very difficult to read the data or very difficult to update or delete the data. And unauthorized access, we cannot control access of users accessing the file system, and more than one user cannot access the file system at the same time. And backup and recovery is also not possible. So if we need to take a backup, we have to create a complete copy, and if that copy is also not available, so we cannot recover the lost or corrupted data. So these are all the issues with the file system. So file system is the basic way of storing data, and these are all the issues with file system, for which we are going to use DBMS. And there are different also, the one tier and two tiers. So in one tier architecture, so the users are directly connected to the database engine, and they can access the data directly from the database engine itself. And two tier architecture, we have an application layer in between the database and the user. So the users will interact with the application retrieves or modifies data onto the database management system. So here users are not directly connected to the database management system. And there is a three-tier architecture. So here the users connect to the presentation layer only, even they are not going to connect with the application layer directly. And the presentation layer receives the information from DBMS through application layer. So dashboards is an example for three-tier architecture. So in the dashboards like stock exchange dashboards and all, we'll be just able to view the information from the presentation layer only. And this presentation layer receives the information from the back layers. And the actual data is stored in the database management system. So basically, the backend data is all stored in the databases. The front end users will access the backend data through different layers. So this is the three-tier architecture of accessing the data. And there are different models available to store and update data, different database management system models, ER model and relational model. Hierarchical model, it is in an inverted B-tree structure. So where table, and these are all the child tables. And network model, so there will be relation table with the other table. Accessing is data is easier in network model, a bit difficult in the network model. And entity relationship model, there will be relationship between the attributes and the relations. So here it is an entity relationship. It is a completely different concept. We have to go deep into it to learn more about it. And relational model, where the data is stored in the form of tables. In the tables, the data is stored in the form of rows and columns, and each table can be connected with the other table with a common columns. So here we can see this table is having student ID, and this table is having subject ID. And one more table, it has a common information, student ID and subject ID, and the marks is listed out here. So we can use the SQL queries to make modification to any of the table or to retrieve the information from all the tables together. So these are the different types of models. So we'll discuss what are ER diagrams and how it can be used in our RDBMS, Relational Database Management System. So we are going to deal with a lot of data as a database administrator. So before that, we need to know like how the data is stored inside the RDBMS. In RDBMS, data is stored in tables, and these tables are all collected together as a database. So this is a database, and inside this we have multiple tables, and each table will be related to other table. In an organization, there will be multiple departments. I'm just giving an example. In an organization, there will be multiple departments, and all the departments are part of the same organization. So there may be relations between, or the relations or dependencies between one department to another department. So for that, there should be relations between the department, and we are going to see how the relations can be set up. So for setting up the relations, we are going to use entity relationship diagram, and entity is any real world object. So it can be a table or a user, a person, anything, we call it as an entity. So here it is. So entity can be a object, person, or a class. So it is a real world object actually. And there will be properties for the entity, and we call it as attributes of the entity. And we are going to set up relation based on entities and attributes. And usually in ER diagram, entity is represented in the form of a rectangle. So a simple rectangular box represents the entity. So here student is one entity and subject is also an entity. And the relationship between the entities is represented in the form of a rhombus or a diamond box. So it is a relationship, and it can be a strong relationship or a weak relationships. So if it is a weak relationship, it is represented with double rhombus box. And every entity will have attributes. So as every person will have a few attributes, every entity will also have an attribute. For example here, so if you consider book as one entity, so a book has an author and the date of publish as well, when it was published. So there may be some other attributes also, like in which language it is published, and in which are all the countries it is published. There are different attributes for a book. So for every entity, there will be attributes, and attribute is represented in the form of ellipse. So we are not going to use this in database administration, but it is good to know about all these things. So these are the basics of our data DBMS. And we have discussed an entity is represented in the form of a rectangle. So there will be weak entities also. That is the entity that is dependent on another entity. We call it as a weak entity. And it is represented in the form of double rectangle box. For example, installment is part of a loan. So installment itself cannot be a direct entity. So it is a weak entity here. And as we discussed, there will be many attributes to the entity, and there will be one entity through which we can like that will be the main attribute for the entity, and we call that entity as a key attribute. And key attribute are represented by underlining the attribute name inside an ellipse. And derived attribute for an entity. So this attribute is derived from another attribute. For example, date of birth will be one attribute for an entity of a student, and age of the student can be derived from the date of birth only. So this is an derived attribute, and derived attribute is represented in this way. So inside a ellipse, there will be one more ellipse, and that ellipse will be in a dotted format. So usually the architects should require all these things. So to set up the environment. And multi-valued attribute, and this attribute that has multiple values. So for one attribute, there can be a multiple values which can be represented in the form of double ellipse. And composite attribute. So composite attribute will have an attributes for itself again. So there will be different attributes for that same attribute. We will see with examples again. So as we discussed, entity is a real world object which has attributes, and there are different types of attributes as we have discussed now. And the relationship between the entities is represented in the form of rhombus or the diamond box. For example, here employee and department are two entities, and these two are related with works for. That is, employee works for a department. So if anyone has any doubt at any time, you can stop me anytime. And as discussed, loan and installments are two entities, but installment is dependent on loan entity. So installment is a weak entity here. And attributes is the characteristics or properties of an entity. So if you consider student as an entity, so it has attributes like name, address, ID of the student, age, and we can also have department, class. So all these are the properties of an entity, and we call them as an attributes. And key attribute through the attribute through which we can uniquely identify, or we can identify the entity, we call it as a key attribute. So as discussed, it will be represented by underline. So composite attribute, so as we discussed, an attribute that has more attributes to itself. So address is one of the entity here. So in address, there are again all these values should be included. So address should have a city, address value should have state, and pin code or zip code cell. And we call the address as a composite attribute here. And relationship we have seen already, and this is one more example. Teacher and student are two entities, and these two entities are related in the form of teachers. So the teacher teaches to the student, and there can be different types of relation that exist between the entities. So they are one-to-one, binary, recursive, and ternary relationship. So if it is a binary relationship, it is a one-to-one relationship. So student is enrolled in one course, and there can be one more relationship, like one student can be enrolled in multiple courses also. So there is possibility of student enrolling in multiple courses. And many to one relationship, in this case, many students will be enrolling to one course. And there is many to many relationship. So many students are enrolled into many courses that is available in the institute. And recursive relationship, so an entity that is having relationship with itself. So for example, let's consider employee as an entity. So employee is managed by one more employee. So one employee manages multiple employees, and here employee itself is managing, and if and employee itself is managed by. So this is a recursive relationship with itself. And next is a ternary relationship. So it is a three-way relationship. So it involves three entities at least. So in binary relationship, so we have two entities. Uh, we should have at least two entities, and in binary relationship we have multiple relationships: one to one, one to many to many, and one to many. And we have one more relationship called recursive relationship, and we call this as a single relationship also. That is a relationship for the entity with itself is called as a recursive relationship. And relationship between two or more entities, it is a ternary relationship. It involves three entities. So here the company operates in sector producing some products. So these three are related here with a different attributes. And the enhanced ER model is necessary for proper modeling of data inside the databases. And this modeling includes three categories. They are generalization, specialization, and aggregation. So the generalization is a bottom-up approach. So here we are having multiple entities and we are generalizing it into a single entity. So we have account types called savings and current accounts, and it is generalized into a bank account. So here we call this entities as a subclass, and these are the superclass. And we have specialization. Entity, it is divided into specialized cases. So if you consider student as one entity, a student can be an old ex-student, or it can be a current student. So getting down from the top, we call it as a specialization, and for bottom-up approach is a generalization. And aggregation, in aggregation we'll have one entity, and inside that entity there can be another relationship also. So if you consider this example, the visitor visits an institute to get the information both about the center and the course as well, both about the institute as well as the course. So the student is going to inquire these both details from the institute itself. So student will not just come to get to know about the course or come to get to know about the center only. So here this combined together, it is an entity, and this is called as aggregation. So based on this ER model, relational database management system is modeled, and RDBMS is introduced by a computer scientist called EF Card, and he has given some rules to be a successful relational database. For a successful relational database, this database should follow the rules that is provided by EF Card. And we have a total of 13 rules, and it starts with rule 0. So for a database to be a successful RDBMS, so it must be able to manage database entirely through relational capabilities. So as we have discussed now about different types of relations, so the database has to be managed through relational capabilities. That is the rule 0. And rule 1 is the information rule. So in the information rule, the data has to be stored in the form of rows and columns inside a table. So it is in the table we are going to store the data, and the data will be stored in the form of rows and columns. And guaranteed access. So the data has to be accessible. So regardless of, here we are not considering the security as of now. So the data that is stored in the table should be atomic and it should be accessible. And for this we should have a table name, primary row or primary key, that is we should have rows and we should have columns. And there can be null values also that can be stored. If you consider the constraints, null values is not possible. Without considering the constraints, null values should be able to store in the tables, and it can have a different meanings. It can be a missing data, not applicable, or no value. So for all these things we are going to use a common column value called null value. So we are going to store the data and the database information, store the data in the database, and the database information also should be stored in some catalog, and it should be accessed in the same way as the data is accessed inside a database. And to access this we are going to use a language. So it is the same language that we have to use to access database catalog as well as the data inside the database. That is the rule number 4 by EF code. And to access all these things we should use a powerful and well structured language, and we are going to use a language called SQL. It is a structured query language, and we should not be able to access data inside the databases without using this language. Then it is a violation if you are able to access the data without using the language. And if database is violating any of this rule, and it is not a candidate for our DBMS. So all these rules has to be satisfied for the database to be a successful relational database management system. And we can create views on a table, and the views has to be updatable. So we should be able to update the views that is created on the table. And we should perform all these type of operations on the relations, like insert, delete, and update operations should be able to be performed. And also we should be able to perform union and intersection and minus operations on the data. And physical data independence. So some file supporting the table is renamed or moved to another disk, it should not affect the application. For the application, it is only table that is applicable. So the table data is stored actually in a physical files. It is not required for the application. And logical data independence. A table can be split up into multiple views as well. But when the application accesses the table information, they have to get the information as if they are going to get it from a single table. And there can be many constraints that can be applied on a database. And the database should be able to enforce its own integrity. So rather than using a different programs. That is, RDBMS should be independent of the front end. So the structure and the way the data is stored inside the database should be independent of the front end. So actually the database is a backend where the data is stored, and in the front end there can be different applications that uses the database for storing and accessing the data. And RDBMS should be independent of the structure of the front end. That is, front end should not affect the way we store the data in the backend. And distribution independence. So we can store data in multiple locations, but for the application, it should resemble like they are getting the data from a single location only. So nowadays the database can be geographically distributed by using cloud environments. So the cloud data centers are located in multiple locations. So if one location is down, so the cloud providers will bring up the data in some other location. But for the application who is accessing that data from office or from their home, so it is like they are getting it from a single location only. And non-subversion rule: if low-level access is allowed to a system, it should not be able to subvert or bypass the integrity rules. So if you provide some access to the system, some users, so the user should not bypass the integrity rules that is already set up on the system. For example, if encryption is set up on a database in a table, and even though the user has his read permission to read the data from that table, if it is an encrypted without proper certificates, the user should not be able to access the data. So all these rules has to be followed by a database to be a relational database management system. And these rules are set up by EF card, and he also designed a relational database management system based on these rules. And our SQL Server is a relational database management system. So apart from SQL Server, Oracle is also an RDBMS. So in our relational database management system, the data is stored in the form of tables, and inside the tables, it is stored in the form of rows and columns. And the relations, we call it as a tables, and the rows inside the tables, we call it as tuples, and the attributes are called as a column. Table is a collection of data elements that is arranged in the form of rows and columns. So this is an example of a simple table, and we are able to see it in our server as well. So this is a database. Inside the database, we have tables, and inside the tables, the data is organized in the form of rows and columns. This table has 16 rows, and there are 4 columns in it. And there are tables with multiple columns as well, multiple columns and rows. So this table has more than 1000 rows, and we have multiple columns in it, and there are different types of data that is being stored in each column. So in RDBMS, the data is stored in the tables in the form of rows and columns. And we call the row as a tuple and attributes as a columns. And table is a relation. And the table should also satisfy relational integrity constraints. There are 3 types of constraints: key constraints, domain constraints, and referential integrity constraints. So for key constraints, there are certain type of rules that needs to be followed. For example, some key columns should not hold the value of null values. There should be some or the other value for the key column, and it should not be null. And domain constraints, it is like, for example, if you consider a phone number or a mobile number, it should not exceed more than 10 digits. So it should have value less than 10 digits only. It is a domain constraint. And referential integrity constraint, if there is a relationship between one entity and another entity, so the other entity also should exist for a referential integrity constraint to hold true. So without 2 tables, we cannot set up a relation with another table. Comparing the ER diagrams that we have discussed and with the relational model or DBMS. So entity is an table here. Entity in ER model is changed into a table, and the attributes of the entity is the columns. And the values that we are storing for these attributes, these are called as row values or tuples. And relationship between becomes a relationship table. So we have 2 entities here, teacher and student. So one more additional table can be created by using these 2 entities, teacher and student, and we call it as a student teacher table. So that is, we can store the information about both student and teacher in a common table. So this is the basic information about RDBMS. So if you go deep, we will get to know about more details like what is primary key, what is foreign key, all these things. So not required as of now. So these are the basic things that we need to require. and we need to know about SQL Server, SQL language as well. It is a structured query language through which we interact with the RDBMS. And by using SQL, we can perform operations like DDL, DML, that is data definition language, data manipulation language, and data control, transaction control language. We call it as TCL and data control language. So to store and access data from the SQL Server, we have to use a language called structured query language. And by using structured query language, we can perform operations like creating creating objects like tables, indexes, all those things we call it as objects. And into that we have to store data, and we store and update data by using insert, update, and delete statements, and we call them as DML statements. And creating and altering the tables, we use DDL statements, data definition language. So in data definition language, we can do create, alter, truncate, drop, and rename of the objects. And the data inside the objects is manipulated by using DML languages. For this, we use statement types like insert, update, and delete. And transaction control language. So if you perform any transaction, if you want whether the transaction to be committed or rolled back, we have to use the transaction control language for this. So if it is commit, we are going to permanently save the information modified by the transaction. So if you doesn't want the change to be modified, we can undo the change, and we can set up save point to save the information for a temporary purpose. And to grant and revoke the permissions on the objects or on the data, we use data control language. So by using DCL, we can grant and revoke the permissions. And to extract the information from the tables that is inside the database, we use select statement. So the basic objective of SQL Server is to store and retrieve data. So by using SQL, we are going to store data into the SQL Server, and we are going to retrieve the data from the SQL Server. So SQL Server is an application from a database application from Microsoft, which follows RDBMS rules. So Microsoft SQL Server is a relational database management system where the data is stored in tables. Inside the tables, it is stored in the form of rows and columns. And let's get into the details about SQL Server now. So we have got some basics set up now. So let's start discussing about SQL Server. So how it has started and how it has evolved over the years, we'll discuss now with history of SQL Server. Microsoft SQL Server is a database application from Microsoft, and there are different database applications available in the market like Oracle, DB2, SAP, HANA. So there are different types of databases, and Microsoft SQL Server is one of the database applications similar to that. And it follows the relational database management system, that is RDBMS. And SQL Server was first introduced in the year 1988, and it is introduced in collaboration with Microsoft and Sybase. So it was a joint venture of Microsoft and Sybase in 1988, and later it was parted. They both parted their ways, and Microsoft has released their own version, the first own version in the year 1994. It was SQL Server 6.0. And the next release was SQL Server 7.0, and it was in the year 1998. And there were many modifications from 94 to version 6.0 to version 7.0. So anyways, both these versions are deprecated now. It is not being used currently. And from the year 2000 onwards, uh, Microsoft has started appending the year name along with the version release. And first in that list is SQL Server 2000. And there were many enhancements from 7.0 to SQL 2000. So the OLAP services was in SQL Server 7.0, and it was replaced with analysis services, which we are still using, that is SQL Server Analytical Services. And till 2000, SQL Server 2000, so we were using different tools to perform different tasks. So we should have an idea of which tool to use to perform a certain type of task previously. But all the different tools are integrated together, and it was introduced as a SSMS. We call it as SQL Server Management Studio. Like all the managing operations can be performed from the single tool. So it was introduced in 2005, which has eased the way we work on the SQL Server. So even now we are using SSMS to connect to the databases or the SQL Server and to perform our tasks in it. And also SQL Server Integration Services was first introduced in SQL Server 2005 version. Previously it was called as a Data Transformation Services. So it is an ETL tool for extracting, transforming and loading of data. Previously it was Data Transformation Services, and it was transformed into SQL Server Integration Services. And the next release is SQL Server 2008. So there are many auditing options included in SQL Server 2008 version, and also the backup compression is also introduced. So we, as a database administrator, we will be dealing with very large size databases, and we should also take the backup of databases. By taking the backup of very large size databases, it is going to occupy additional space. So we have an option of compressing the backup files from SQL Server 2008, which was not available in the previous versions. And the next release was SQL Server 2012. So in 2012, a new high availability feature called always on high availability was introduced. So previously it was mirroring, and it was enhanced to into a always on high availability. And it has there were more enhancements made on always on high availability in the later versions for the ease of maintenance and for the ease of setting up. And the next release is SQL Server 2014. From 2014 onwards, Microsoft has started using cloud premises for storing the data. So we can store the data in Azure cloud storage as well. And there were enhancements made on the features that was introduced in the previous versions, like always on and column store indexes. There were many enhancements made to them. So this is till 2014. There are still more releases from Microsoft. So now let's learn about the other versions of SQL Server. So after 2014, there was another release called SQL Server 2016. So the next release after 2014 was 2016, and there are many features for every version release. There will be many new features will be added, but in a database administrator perspective, not all the features are required for us. So in 2016, the new features as part of database administrator perspective is security. So here we have new features like dynamic data masking, row level security, and always encrypted. So these new, by using these new features, we can enhance the security of data that is stored in the SQL Server. And these all other features are for developers and other users. And the next release is SQL Server 2017. So soon after 2016, 2017 was also released. So it is having the same features as 2016, but only additional things in the 2017 is 2017 can be installed in Linux and Ubuntu systems as well. So previously till 2016, starting from SQL Server 7.0 and 6.0, we can install SQL Server only in Windows operating systems. So we are not able to use it in Linux or Ubuntu systems till 2016. But Microsoft has started supporting SQL Server in Linux and Ubuntu systems as well from SQL Server 2017 onwards. And many more enhancements from the developers perspective, like Python language support is introduced, Docker containers can be used, and enhanced query processing is also introduced in 2017. So the query executions would be faster compared to the previous versions. And the next release and the latest release in the market is SQL Server 2019, and it is developed more in considering the developers and considering the machine language and artificial intelligence. But compared to 2017, we have intelligent query processing, which enhances the query performance, and also in-memory database. Like we can create a database completely inside the memory, so which is easy to access. The speed of accessing the data will be quicker by using in-memory database. So these are the new features available in 2019. And with every version, there are different editions released by Microsoft. It depends on licensing costs and the feature availability. So with every version, they will release different editions like Enterprise, Standard, Express, and Web editions like this. And we are to install SSMS. So SSMS is the tool, graphical user interface tool, to connect to the SQL Server. So once we install SQL Server, we'll get one more tool called Configuration Manager. So you get SQL Server Configuration Manager on installation of SQL Server. So if any server, if you want to know whether SQL Server is installed or not, we can search for Configuration Manager. So here we'll be able to see the SQL Server services. So these are the SQL Server services. We'll start and stop the service, and we make configuration changes of the SQL Server in Configuration Manager. So now we have to install SSMS. So SSMS is a free tool from Microsoft. We can download it directly from Microsoft website. So we have to download the file and we have to install it. So download is completed. We can start the installation. So this is the SSMS file, and we can just run it as administrator. So there is no much steps in installing of SSMS. The only thing is we have to choose the location where we want to download SSMS, and we can just click on install. So now we have installed one instance of SQL Server. Let me put it this way. So we have created Windows Virtual Machine. Let's assume this is Windows Virtual Machine. And let's assume it has 16 GB of RAM. And there are 32 processors. Or let's assume we have 4 processors. And we have a total of 1 TB of disk space. So in multiple drives, let's assume we have 1 TB of disk space. And we are installing SQL Server. Now we have installed one SQL Server instance. And this SQL Server instance would occupy or would consume 8 GB RAM, and it does require 2 CPUs, and it requires 500 GB of disk space. So the remaining resources is left over, and it is just sitting idle. So usually the organization has to pay for all these resources, but we are using only the part of resources that is available, and the other resources are just sitting idle, and it is waste of money. So to optimally utilize these resources, we can create one more SQL Server instance on the same host, and we can call it as SQL instance 1. So it is one more copy of SQL Server, and it can use the remaining resources. So like this, we can optimally utilize the resources, and each SQL Server instance is independent of each other. So this is going to be a different SQL Server instance where we have set of system and user databases. We have set of system and user databases, and in another instance also we'll have a different set of system and user databases. So like this, we can create multiple instances in one host itself, and each instance will be independent of each other. But whenever we are installing SQL for the first time, it will be the default instance. So whenever we are installing for the first time, it will be default instance, and any instance after the first instance installation, it will be the named instance. So to connect to the default instance, we have to give the same name as the Windows host name itself. For the named instance, along with the Windows host name, we have to give the name of the instance as well. So we'll see that as well. Now we have done a default installation as of now. So we have installed SSMS. After SSMS is installed, it is asking us to restart the server. So for the changes to be complete, we have to restart it, and we can try to connect it back again. So like this, we can create multiple instances in one host itself to optimally utilize the resources. And one more advantage with instances is, so different application may require different SQL servers. So we can host different SQL servers on a same host itself. So these are the advantages of instances. So each instance is one copy of SQL Server. So like this, we can have multiple copies of SQL Server in one Windows machine. So a simple example is we can have two or more WhatsApp application in a single mobile. Each application will be different for a different phone number. So the server got restarted, the virtual machine is restarted now. Now we can connect to SSMS. And through SSMS, we can connect to the SQL server that is installed. So it is the default instance that we have installed now. So actual work starts from here, right? So from installation itself, the actual work gets started. So, but we are not going to install every time, right? So once installation is completed, so we are going to use the SQL Server for storing and retrieving of data. So this is the one of the SQL Server instance where only system databases will be available by default. They are master, model, MSDB, and TMDB. And there is no user databases as of now, as it is an empty instance where no user operations is being performed in it. So this is one instance of SQL Server, and this is the default instance. And to connect to the default instance, it is the same name as the Windows host name. So we can get to see the Windows host name here. So the computer name. So it is the same name as the Windows host name through which we connect to the SQL Server. Now let's install a named instance as well. So to install the named instance, again we have to follow the same process of installation. Setup. So I'll use the same files which I have downloaded, and as administrator. Installation, SQL Server standalone installation. So as we have already SQL Server installed in it, we have an option to choose add features to an existing installation. So this is going to add any features that we have missed in the last installation. But here we want to create a new installation. So I am choosing perform a new installation. And it would be the developer edition. We have to accept the license terms. And we have to select the features. So we can select the features, and so we have to choose the root directory. So again, I'm choosing the C drive itself, as I don't have an additional drives here. And it is a named instance, and we have to give the name for this. So we can give any name. It cannot be default instance because the default instance is already installed. So it will be the named instance only. And we have to choose the service accounts and provide the collation details. I'm going with the default details here. And we have to create a system admin account which has a complete permission on this instance, and we have to provide password for this as well. And we have to add the users who wants to be the system admin account, who want to be system administrators on this instance. So I'm not choosing any of this here. And we can click on install. So in one host itself, we are creating two instances here. And in an organization, there will be different applications that will be serving the business. And each application can store their databases in different instances by creating multiple instances. So the installation would take some time. So the installation is complete now. So if you go to configuration manager, we will be able to see two set of services. So here we can see two set of services. So this is the default instance. Default instance will always be like MS SQL Server. And named instance services, it will have the name of the instance in the brackets. So we have two different instances of SQL Server in our host, and we can connect to the other instance as well. And we have to give the name of the instance to connect. So now we have two instances in one host, and each instance is independent of each other. For example, if I create a database in this, So here we can see I have created a database here, and this database is specific to this instance only. Here we can create one more database. So it has its own set of system databases. It has its own user databases. And this instance will also have own set of system databases, and it has its own user databases. Jobs, everything is independent of each instance. So like this, we can create multiple instances in one host itself. And there are a few more things to learn about instances, like how many number of instances we can create in one host, all those. So each instance is one copy of an database engine, and we can have multiple instances in one host itself. And there are two types of instances. One is default instance, the other one is named instance. So whenever we are doing the installation for the first time, it will be the default instance. And even the default instance also, we can make it as a named instance during installation itself. But whenever we are installing the SQL for after the first installation, it will be always the named instance only, and we have to provide the name for the named instance. So the second installation and the more any installation after the first time, it cannot be default instance, it can be only named instance. And we can have maximum of 50 instances in one host, but practically it is not feasible. It becomes overhead of maintenance. So usually we will have 2 to 3 instances in one host. So if it is a cluster, we can have 25 instances. Even a cluster with SMB file share, we can have 50 instances. But we will never have 50 instances in one host, because it is overhead of maintenance, and the resource utilization will be very critical. So we'll have maximum of 2 to 3 instances per host. And the advantages of having instances is we can have more than one copy of SQL Server hosted in one machine, and we can optimally utilize the resources. As I have shown you in the diagram, we can optimally utilize the resources between the instances. And there may be different applications for a business. Each application can have their own SQL server, and still the SQL server is independent of each other. So for example, let's assume a business has banking and insurance. So they can store all the banking information in one SQL Server instance. And all the insurance information in one more SQL Server instance. The two are independent, but they both are staying in the same host. So like this, for different application, we can have different SQL Server instances. So now we have seen how to create multiple instances and how to connect to multiple instances as well. If you want to delete any one of the instance, so how to do it? So to delete the instance, we go to control panel, uninstall a program, and we have to click on uninstall here. So we have three options here: add new features, repair the product if there is any issues, or remove the product. So let me choose remove.
What do you mean by repair the product?
So if there is any errors, it will use the existing set of files to repair those features. And here we have to select which instance we have to uninstall. So I'll choose instance 1. We'll select only the instance features. So these are the shared features. It is the same for both the instance. So I'm not going to uninstall the shared features. I'm going to install only instance specific features. And you can click on remove. So this will remove the instance that we have created now. That is a named instance. So we can remove default instance also if default instance is not required. So instead of named instance, we should have chosen the default instance that is with name MS SQL Server. So as the number of features is very less, it got completed quickly. So now if you go to the configuration manager and refresh it, so you can see there is only one set of services now. So like this, we can install multiple instances and remove the instances as well. And after installation of SQL Server, we have to make few configuration changes. So let me show you what are the configuration changes we need to make. So in the SQL Server network configuration, there is 3 protocols: shared memory, named pipe, and TCP IP protocol. So it is this through these protocols, the clients connects to the SQL Server. So by default, shared memory will be in enabled state. Named pipe and TCP IP will be in a disabled state. So we have to enable them back. And if you are making any changes in the configuration manager, so here we can see any changes made will be saved. However, they will not take effect until the services is stopped and restarted. So we have to restart the SQL Server services here. So I'll explain you why we require these protocols. So for example, we have a Windows server and we have SQL Server instance, and if the application server is also on the same server, so the application and SQL Server are hosted on the same Windows server, then it requires a shared memory. So they are going to share the same memory that is available in the host. So in this case, shared memory protocol has to be enabled. So anyway, by default, shared memory will be in an enabled state only. And for example, if the application is in a different server, in different Windows server, so for the application to connect with the SQL instance, the named pipe protocol has to be enabled. So this is in case if the application server and Windows server or SQL server are on the same local area network. So if the application server is out of the local area network or the network, so we require TCP IP protocol to be enabled. So if TCP IP protocol is not enabled, the application that is outside the local area network cannot connect to the SQL Server instance. So depending on where our application is hosted, so we have to enable the protocols. So this is one of the configuration change we have to make after the installation of SQL Server. So the next configuration change, we have to do it from SSMS. So this instance is no longer available. If you disconnect and if you try to connect back, will not have the instance because this instance is deleted now. And coming to the available instance, so here also we need to make few configuration changes. We go to the properties of the instance. So one is memory. So as I told, we are getting these options during the installation also nowadays from 2019. So after installation of SQL Server, if you want to restrict the memory of SQL Server, so we can restrict here. We can give the minimum memory and maximum server memory. So it is always best practice to restrict the memory usage of SQL Server. And we restrict memory usage to 75 to 80% of the available memory. For example, in a host, if you have 10 GB of memory, we can restrict SQL Server to use 7.5 to 8 GB of memory. So the remaining memory should be left out for the OS. So if you don't restrict the SQL Server memory, maximum memory, so the behavior of SQL Server is such that it consumes all the available memory. So it makes even OS to starve for the memory. So for that reason, we have to restrict the memory usage of SQL Server. So here I have only 4 GB of memory for my server, so I'm not restricting it. So if you have more memory, we can restrict SQL Server to use the required amount of memory. And coming to the security, so SQL Server can be connected two ways. One is through Windows logins and the other one is through SQL Server logins. So let me show you what is Windows logins and what is SQL logins. So we have Windows logins and we have SQL logins. So Windows logins are usually created in Active Directory and added to the SQL Server instance. Whereas SQL logins are created in the SQL instance directly. And for Windows login to connect to the SQL instance, Windows login has to connect to the Windows server first and then connect to SQL server. So it is two levels of authentication required for Windows login to connect to the SQL server. So Windows logins are treated more secure compared to SQL logins. Whereas SQL logins, they can directly connect to the SQL server without logging to Windows. So let me show you how we can do both of this. So here my server is not part of any Active Directory. So I'm going to create logins on the Windows level. So I go to computer management for that, local users and groups. I'll create new user. So we have created two users at Windows level. Now these Windows users can be added to the SQL server. So to add the Windows users, we go to logins, new login, search, it is Windows authentication users, and I'll search for the username. So user is available, so we are able to find. For example, Uday14 is not available. If I try to find, it cannot find the object. And we can provide them the required permissions. So now I have created a Windows user here. So like this, we can add one more user also. So Windows users, they have to be first. So if it is SQL logins, we can directly create in SQL Server instance itself. So we choose SQL authentication. So let me give the name as test login. We have to provide password. I'm just creating a login and I'm not provisioning any additional permissions to it. So I have created a test login, which is SQL authentication login. And if SQL authentication login wants to connect to SQL server, we choose SQL authentication. So we can connect to the SQL server instance from here itself using SQL login. But if the Windows login wants to connect to the SQL instance, they should have permission to Windows also. I'll show you how it works. So for Windows login to connect to SQL server, they have to have login like permission at Windows level as well. So for example, if Uday12 wants to log into the SQL Server, they have to be member of administrator group. So object types, it is groups. So I'm going to connect to the same Windows SQL West DB. So in the more choices, we have to use Uday12 here. So if the Windows login wants to connect to SQL Server, they have to log into Windows first, then they have to connect to the SQL Server through SSMS. But if it is a SQL login can directly connect from anywhere to whichever server the remote access is enabled. So here we can see it is connecting with Uday12. So if you want to connect with Windows login, no need to provide the permissions because no need to provide the password because the password is authenticated at Windows level itself. So we can have like for one server, we are having 3 connections as of now. So here we have 2 connections. One is Uday KR, the other one is test login, and we have one more connection as Uday12. So like this, we can create logins and we can connect to the SQL Server through the logins. So if you want our server to be more secure, so we can just allow only Windows logins to connect to the SQL Server. So in that case, SQL logins will not be able to connect. So as SQL logins are less secure, so in very critical environments, they allow only Windows users to connect. So for that, we use Windows authentication mode. By choosing Windows authentication mode, and after making these changes, it requires restart of server. So restarting of SQL services should not be done again and again. So once the server is in production, we should never restart the services because restarting is a downtime for the application, downtime for the business. So we should never restart the services once SQL Server is in production. And now I'll try to log in through SQL login. So we are able to connect previously. Now we are not able to connect. So test login for failed for user test login. So let's check the reason for this. So we can find the reason in the SQL Server logs. So login failed for test login, and we can find the complete reason. So server is configured for integrated authentication only. That is, it is configured only for Windows authentication. So only Windows users will be able to connect. SQL users will not be able to connect. So if you want SQL users also want to be connected to SQL instance again, we can change the security back to SQL and Windows authentication mode. So even after this, we need to restart the services. So any of these changes, it has to be done during the installation and soon after the installation only. Once the server is provided to the production and the user starts using it for production work, so we should never make any configuration changes and we should never restart the services unless requested. And that too with the proper approvals and proper change management, we have to restart the services. So whenever we install SQL Server, we'll have a configuration manager tool available where we start and stop the services. So we have 2 major services. One is database engine services. The other one is SQL Server agent services. and this is a new server I have installed. So I have to enable named pipe and TCP IP protocol. So we have discussed why we require this protocol. So if the servers are part of same local area network, then we require named pipe protocols for communication. And if they are not part of same local area network and they are connected over the network, so we require TCP IP protocol for communication. And if you are making any changes in the configuration manager, it requires restart of SQL services. Then only the changes will take effect. And we connect to the SQL server through a tool called SQL Server Management Studio. So as it is loading for first time, it takes some time. And here we have discussed about setting up the maximum memory. So the best practice of setting up maximum memory is we have to restrict SQL Server not to use more than 75 to 80% of available memory. So if it is not restricted, so the behavior of SQL Server is such that it consumes all the memory without leaving anything for OSS. So if you go to the properties, so we have seen how to set up the maximum memory. Here we have to give the maximum memory the SQL Server instance can use in megabytes. And we have discussed about security. So there are two types of logins that connect to SQL Server. One is Windows logins, the other one is SQL logins. So Windows logins, we have seen how Windows logins has to connect to the SQL Server instance. They have to be first authenticated at Windows level, then they connect to SQL Server instance. Whereas SQL login, they can directly connect from the same SSMS or any other SSMS if remote connections are enabled. So if you choose Windows only, SQL logins cannot connect to the SQL Server instance. And coming to the connections, if you want to connect to the servers remotely, that is to connect remotely to our SQL Server instance, we have to enable these options. Anyway, by default, it will be in enabled state. And if you don't want our server to enable remote connections, then we can disable this option. So if you want to connect to the servers remotely, we can use allow remote connections to this server. And this is the database settings. So this is the data file, log file, and backup locations which we have selected during the installation of SQL Server. And at later point also, if you want to change the default locations, so we can change the default location here. And whenever we are creating a new database, that will choose the default location. So the existing databases will be in the same location only. So these are the few configuration changes we need to make after the installation of SQL Server. So this is one instance of SQL Server which we have installed now, and it has set of system databases. They are master, model, MSDB, and TeamDB database. And we don't have any user databases as of now. So we'll see how to create user databases as well. And before that, let's learn about the system databases. So in SQL Server instance, there will be two types of databases. One is system databases, which we get by default along with installation. And the other one is user databases created by the users. So whenever we install SQL Server, we'll get a set of four system databases. They are master, model, MSDB, and TeamDB. And each has its own usage in working of SQL Server. So let's start with master database. So as the name suggests, it is the master of SQL Server instance. So it is a master of complete SQL Server instance. So all the information about the user databases and the logins is present in master database. And all the configuration information, all the instance configuration information is stored in master database. And master database is critical for the working of SQL Server instance. And the data file and log file of master database is the startup parameters of SQL Server instance. So whenever we restart the SQL Server engine will refer the information from the data files and log files of master database to bring up the SQL Server instance. And if master database is not available, the complete SQL Server instance will be down. We cannot connect to any database, or we cannot connect to SQL Server instance itself, because they are the startup parameters for the SQL Server instance. And as this is a critical database, we do not store any user data in master database. So it is dedicated for the SQL Server instance only, and we should never store any user data in master database. And as a best practice, we have to take regular backups of master database. So due to some reason, if the instance is not able to be connected, so we can create a new instance and we can restore the backup of a master database. So that we can recover the lost information from the backup of master database. So it is always best practice to take the regular backup of master database. So master database is a very critical database for the working of SQL Server instance, and it is the master of the SQL Server instance. So it stores the information about the instance and its configuration. So I'm creating a test database here. No, I just created a database. So select start from sys databases. This information will be stored in master database only. So we can see the information about newly created database got stored in master database. So all this information is stored in master database. Let's see what are the tables that are available in master database. So we have only few tables we are able to see here, but apart from these few tables that we look here, there are few more tables that get stored in master, like that will be part of master database. Like we have seen sys databases, all this will be part of master database. So all this information gets stored in master database only. And the other database is model database. So model database, it acts as a template. So it is the template for creating new database. So now I have just, with the right click of a few steps, I have created a new database content test DB. So but whenever we want to create a database, it requires like we have to set up, choose all the properties and features for the database. So I'm calling this as new test DB. But if you go and see here, so all these options are required to create a database. But whenever we create a new database, we cannot go and choose all these features by ourselves. So by default, all these features will be available for model database, and all the options of model database will be inherited to the newly created data. But after creation or during creation also, we can change the options as per our requirement. But by default, so we were discussing about model database here. The model database acts as a template for creating new database. For example, if you go to the properties of model database, and in one more window I'm creating a new database. So these are the model database properties, and this is the property of a new database that I'm creating. So whenever we are creating a new database, it uses the same properties and options of the model database to create a new database. So model database is used as a template for creating a new database. So apart from acting as a template for creating new database, so there is no other usage of using the model database.
So can
And
we
no
can
user
we
information is going to be stored on model database. For example, one of the property of the database are recovery models. So here I have chosen it as a full. Now I'm going to change it to simple. After changing it to simple, I'm going to create a new database again. So now if you see here, so here it is showing the recovery model for the newly created database to be simple. But during creation, we can change the properties of the database as per our requirement again. But by default, it uses the property of model database. So we can change the properties during creation or after creation also. But only during while creating it inherits all the basic properties of a model database. And we are not going to store any user information in any of the system databases for that reason. And we are not going to store in model database also. So it is not required to take the backup of model database, as it is not going to store any critical information in model database. And next is MSDB. So MSDB, it stores information. It stores information about SQL Server agent. So this is the MSDB, and we have SQL Server agent services. So all the information about SQL Server agent will be stored in MSDB. So like we'll be creating few jobs in SQL Server agent, and we'll also be setting up alerts. So all this information will be stored in MSDB database. So it stores all the information about SQL Server agent, and to access SQL Server agent, the login should have permission on MSDB database. And also apart from the information about SQL Server agent, so backup information and restoration details, so it will be stored in MSDB database only. We'll be able to see those databases. Unlike master database, we are not able to see few databases, but in MSDB we'll be able to see all the databases, sorry, all the tables. So if you are taking the backup of databases, the backup information will be stored in these tables. And if you set up log shipping, the details of log shipping will be stored here, and the job and job history, job schedules. So this is about job history, job schedules, job steps. So all the information about SQL Server agent is stored. And also if you are restoring any new databases, so the restore information will also be stored in MSDB database. So MSDB is one of the system database where information will be frequently getting modified. So it is best practice to take backup of MSDB database regularly. So for example, if any of the jobs are deleted, and if someone has made unwanted modification in the jobs of SQL Server agent, so we can will be able to recover it by using the backup of the MSDB database. And we have to there is possibility of MSDB database getting full because it is getting updated regularly. We have to set up auto growth settings for MSDB database. So whenever we create a database, it will have some default initial size. If you go to files, there will be some default initial size, and we should set up the auto growth settings as well. That is, whenever it is reaching the size that is allocated to it, it has to auto grow in megabytes or in percentage of the previous size. But it is always best practice to set up the auto growth in megabytes, and we can limit the size of the data file, or we can just leave it unlimited. So if it is unlimited, it can use all the space that is available in the disk where the file is stored. So we have to set up auto growth settings as well. So if you don't set up auto growth settings and MSDB gets full, so the information cannot be updated into MSDB database. So for example, if you try to take the backup of a database, and if MSDB database is full, so the backup would fail because it cannot update the backup information in MSDB database. So setting up auto growth settings is essential for MSDB database. And next is the tempdb. So as the name suggests, it is a temporary date, like it holds the temporary information. Or let's call it as temporary data. So if you want to create any temporary tables, so all those tables would be created in tempdb only. So the temporary tables would start with name like this. For example, so we have to give the column name, all those details. I'm just creating some sample table. So I have created this from master database, but if you could see, this table will be created in tempdb. So it should be shown here. Yeah, here is the table. So like this, all the temporary tables will be created in tempdb database, and also all the sorting operations, calculations. So if any of these operations are being performed in SQL Server instance, it will be using the space from tempdb. And tempdb is used by all the users and all the databases. So on all the users who are connected to SQL Server, they'll be using tempdb database, and all the databases can access the tempdb. So for this reason, there will be more input output on tempdb database. So any user is connected to the SQL Server instance, they'll be using tempdb database also. And in a busy environment where multiple user connects to the SQL Server instance, there will be more input output on the tempdb database. So as a best practice, we have to store tempdb files or log files in dedicated drives. So for example, if it is stored along with the same location of the user data files, so it will impact the input output of the user data files also, which in turn impacts the performance of the queries and the performance of server. So as a best practice, we have to store tempdb data and log files in dedicated drives only. And tempdb files tends to grow as more users are connected and more tempdb is used frequently. So auto growth settings is also essential for tempdb database. So similar to the auto growth settings we have seen in MSDB, so we have to set up auto growth settings for tempdb files also. So this is the initial size, and here is the auto growth settings. So we can change the initial size and auto growth settings as per our requirement and how busy our instance is. And if tempdb is full, and if you don't have enough space in the drive for the tempdb to get expanded, So SQL Server cannot accept any other connections. If you try to perform some transaction, SQL Server cannot accept it, mentioning TempDB is full. So TempDB is very critical for the running of any transactions in the SQL Server instance. And we have to handle TempDB such that it has enough space to accommodate new transactions. So if there is no enough space, the transactions cannot be executed. So the transaction would fail, mentioning space issue in the TempDB database. And for example, if the TempDB gets full and there is no enough disk space in the drive where we store the TempDB, we can create new TempDB files. New TempDB files can be created in the location where we have space. So for example, there are 3 TempDB files as of now, 2 data files and 1 log file. So 2 data files and 1 log file. And if I want to create an additional TempDB file, so I'm just giving temp3, and this is the default path. So let's assume in this default path there is no enough space. So in that case, we can choose some other path. Let me create a new folder here. So you can see an additional file is created here. So like this, we can create a new TempDB files on the go. So it doesn't require restart of any services or anything. So whenever all the TempDB files that we are using gets full, we can create new TempDB files. But we should not store any critical data. So manually, we should not store any critical data in TempDB, because on every restart of SQL Server, new set of TempDB files will be created. So the old TempDB files gets deleted automatically, and new set of TempDB files gets created. So whatever information that is there in the TempDB database, that gets flushed out and it is deleted. So for this reason, we should never store any critical information in the TempDB database. It should be only used for sorting calculations or creating any temporary objects, and it will be all done automatically. So we should not. It is not required by us to manually choose particular transactions to happen on TempDB. It all happens automatically. But only thing is, we should not store any critical data, or no critical tables should be stored in created in TempDB database. So TempDB acts as a scratchpad for other user, for all users and for all databases. For example, if you are performing some sorting operations in any of the user database, so that sorting operation will be performed in TempDB database. So it is not going to utilize the space or the resources of the user database. It is going to utilize the space from the TempDB. So once the sorting operation is completed and some results are obtained, then it is returned to the actual user database. But all these temporary calculations, sortings, all these things happens in a TempDB. So it is like a scratch pad for all other users and all the databases. And as all the information in TempDB files are deleted on restart, so it is not required to take backup of TempDB database, and it is not possible also. So it is not required to take the backup of TempDB database. So it is only going to store the temporary information. And whenever we want to know when the SQL Server was last restarted, so we can just see the property of TempDB database and get to see when the date it got created. So this is the time, the last time SQL Server got restarted. So by just looking at the creation date of a TempDB database, we can get to know when the SQL Server was last restarted. So apart from the 4 system databases that we are able to see here, master, model, MSDB and MDB. So there is one more system database, one more read-only system database. It is called as a resource database. So all the version information, so all the information about SQL Server and what type of edition and upgrade information will all be stored in resource database. So it is a read-only database only, and we cannot access the database or we cannot edit the information in the resource database, but we'll be able to see the files. For example, here I'll search for star.mdf. So all the files with the extension mdf will be displayed. And this is the resource database file. I'll show open file location. So it is stored in this location. So this is the data file and log file of master database. So apart the information about the version, edition and all the upgrade information is stored in resource database, and it is only read-only database. We cannot access it from SQL Server Management Studio, and we cannot take the backup of the resource database also. So we can just take the file backup. So we can copy the file and we can place it into some other location if we want to secure these files. So the other databases, we have to take the backups through T-SQL script, whereas the resource database, the backup has to be taken, like the file copy is to be used for taking the backup of for the resource database. And if we are performing any upgrades like service pack upgrades or cumulative updates, so the information in resource database will be used as a reference. So apart from that, there is no usage of resource database. So these are the 5 system databases in SQL Server. So these databases we are going to get by default. So we are not creating it. And as we discussed, each database has its own usage in the working of SQL Server. Now, the business data or any user data will be stored, has to be stored in user databases. So we have to create database and we have to create tables and populate data into it. And there are 2 ways of creating user databases. So here we are discussing about user database. So we can create user database in 2 ways. Create a new database and create tables and populate data. And one more way is create database using the existing backup files. So by using existing backup files, the data will have some existing information also. So we have seen how to create a new database. So just it is right click new database, notice DB, and we can choose the properties and options here, whether the database has to be in full recovery model or simple or bulk log, or if you want to change any of these properties, whether it should be a multi-user database or single user database or restricted user, we can all choose options here. And for everything that we are performing in GUI, like right clicking and performing the task, so in the backend it is implemented through T-SQL script. So this is the T-SQL script for creating a database. Create database name, it is not a contained database, so it is set as none. The data file details, log file details, and these are all the properties required for creating a database. But by just clicking on OK, a database is getting created for us, because all these properties is inherited from the model database. So we can get our database created from GUI, or we can just take a script and we can execute this script to get the database created. So to execute this script, we can just we have to check for the syntax errors. So it is showing some syntax errors. It is telling like new database does not exist. Yes, the database does not exist because it is not yet created. But we can execute this and the database will be created. So here we can see a new database with all the properties we have given here. The database is created based on those properties. And it is an empty database. There is no tables, any user tables inside it. And we can create a database by using existing backups. I'll download some sample backup files from Microsoft website. So I have to change few options to download the files. So usually we don't connect to the internet from our servers. So here, just to get a sample files, I am connecting to internet from virtual machine and downloading the files. For practice purpose, you can do it, but not in production environments. By default, we will not have access to internet. Even though if you have access to internet, we should never access internet from the servers. So I'm going to download some sample SQL Server database backups. So AdventureWorks databases can be used. So these are all the backup files. We can just download this backup file. So here we can see it is not allowing us to download the files. We may need to make few more changes. The file download has to be enabled. So I'm able to download the backup file. Now I'll show you how to use this backup file to create a database. So this has some predefined information in it already, which we can use for testing and practice purposes. So backup file is copied, like downloaded, and I'll take it to some local location from downloads. I'll use the backup file to create a database now. I'll choose restore database. We'll discuss more on backup and restore. Just I'm showing you how to use the existing backup file to create a database. So here we have to choose the location where our backup file is placed. So it is placed here. So you can just click on OK, or we can take the script. So this is the T-SQL script for restoring the database. So it is restore database name. A database with this name is going to be created by using the backup information in this backup file. So this database will be created with one data file with this name and one log file with this name. On 100% completion, a database will be created in the instance. It has some data already. Database would be created in our instance. If we refresh, we'll be able to see the database here. So this is the database we have restored. So if you could expand, so it has some information stored in the form of tables. So it has some data in it. So like this, we can create database like empty database and populate data into it, or we can use existing backup file to create a new database. we'll discuss about database roles. If the permission is provided at server level, it is applicable for all the databases in that instance. But if the requirement is to restrict the user for only the required databases, we have to provision the permissions at database level. So we provide permissions to logins at server level. And if the same logins are restricted to the required databases, at database level, these logins are called as users. So at database level, we provide permissions to the users. And in database level also, we have different predefined roles, and we call them as database roles. So I'll just show you how it would look like. Under databases, if you choose any of the database, and under security, we have users here. So these are all the users who can connect to AdventureWorks 2019. And what are the permissions that can be provided on databases is the database roles. So here are the database roles: access admin, backup operator, data reader, data writer, DDL admin, Denny data reader, Denny data writer, owner, and security admin. So we can provide these permissions for the users on the database. And similar to server level, each role will provide a different privilege to the user. So let's discuss in detail what privileges it provisions to the user by going through the database roles. So similar to different roles at server level, we have different roles at database level as well. They are DB owner, security admin, access admin, backup operator, DDL admin, data reader, data writer, Denny data reader, and Denny data writer. We can provide any of these privileges depending on the requirement of the user. So let's see what is each role and what each role will provision to the user. So DB owner, as the name suggests, DB owner will be the owner of the database, and the owner will have a complete privileges on that particular database without any restrictions of any security features. So once we provide DB owner permission to the any user, the user will be able to access all the features and all the objects in the database, including data. So it is very critical permission, and we should not provide these permissions to most of the users. In rare cases, we provide these permissions to application users, and that too to very few users only we provide DB owner, because DB owner can also modify data, delete data, or grant or revoke permissions onto the database. So there is no restrictions for DB owner on that particular database. And next is the security admin. So this is similar to security admin at instance level. The DB security admin can grant or revoke the permissions of other users onto the database. And usually we should not provide these permissions to the application users, because once we provide this permission to application users, they themselves will grant or revoke their permissions. And also, as it is very little used, it should be included in audit. And next is access admin. So access admin can block the sessions of other users. So this is similar to process admin at instance level, and this is one more role which should not be provided mostly for other users, and it should be included in audit exceptions. And next is a backup operator. So this is most usually provided permission to the third-party tools who work on taking the backup of the databases. And also in some cases it is provided to junior DBAs whose work is to take the backup of database. So to take the backup of a database, the user should have minimum of backup operator permission. So without backup operator permission, the user cannot take the backup of the database. And again, this role is not required for the application users. It should be either for third-party utilities, or it should be restricted only to the database administrators. And DDL admin is one more critical permission, because the user with DDL admin permission can perform all the DDL tasks like create, alter, drop of tables or indexes, and some other objects can be done by DDL admin. Like dropping a table will drop all the entire data in the table. So there is possibility of misusing the DDL admin permission. So this permission should not be provided to any other users, especially in production environments. And we should never provide these permissions to the application users. And data reader, so this is usually provided permissions to the application users also. So the user with data reader permission will be able to read the data from all the objects in the database. For example, if a database has some 100 tables, with data reader permission, the user can read the data from all the 100 tables. And data writer permission, with data writer permission, the user can perform insert, update, and delete operations on the data in a table or in the objects. So updating a data or deleting a data, it cannot be done by all the users because we'll be dealing with the critical data. So any unwanted modifications or unwanted deletions, it will impact the business. So data writer permission should not be provided to all the users again. And application users also should not be provided with data writer permission. And to have a data writer permission, the user should have data reader permission as well. So without data reader permission, if the user has data writer, they cannot modify the data. And if the user is having data reader permission, and if you want to implicitly or deny the data reader permission, we provide any data reader. So instead of this, we can just ignore the user from providing the data reader itself. So same way we have any data writer. So insert, update, and delete operations will be denied to that user who has data writer permission. So we can revoke the permission of data writer instead of providing both data writer and any data writer. There are total of 11 fixed database roles, and they can provide 77 different database privileges to the user. So data reader can perform select operations. Any data reader, it denies the select for the user. A data writer can perform insert, update, and delete, and these are denied for any data writer. Access admin can alter any user, and you can disconnect the connections of other user as well. And security admin, so security admin can grant and revoke the permissions, and also security admin can create a new database role also. So it is very critical permission, because security admin who can create a permission almost equal to DB owner. So there is a possibility of misusing the permissions. And backup operator can take the backup of a database, take the backup of transaction log file, and also can perform checkpoint operations. And DDL admin can perform all the DDL operations like creating, dropping of objects. So let's see how to provide these permissions to the users. And also we haven't tested the instance level permissions as well. So let's test first instance level permissions, and then we go to the database level permissions. So to provide permissions at instance level, we go to security, and we should have the logins available here. If not, we can create either a Windows login or a SQL login. So for example, I'll take a SQL login, which I can test here. So server roles. So these are the available server roles. For example, we'll create provision a DB creator permission for the user. For new SQL login, I have provision DB creator permission now. So with DB creator permission, the login will be able to create a new database. The login has created a database testdb123, and this login will be able to access only this database. And if the login tries to access other database, it is not accessible. So with the DB creator permission, the login can create a database and access that particular database only. So the next permission which we can provide is new SQL login. Okay, let me provide the process admin permission for this user now. And usually in the real work environment, there will be multiple users under the logins. So if you want to find the login, we can filter out the login information here. So you can just right click on logins, filter settings. So the name contains test login. So then we'll be able to find only that login here. And if you want to remove the filter, we can just go to filter and remove filter. So because it is difficult for us to find the actual user if there is hundreds of logins available. So we can filter out the required login information, and we can check the permissions or grant and revoke or any task that we want to do on login. We can do it after filtering. So now I have provided process admin permission. So now let's see what the process admin can do. So through one connection, I'm going to execute a select statement, and I'll make it to execute for 100 times. So the process admin can kill the connections of other users or other logins. That's what we are going to try here. Now I'm going to make one connection. So the query is still executing. So from another session, I'm going to kill it. The query got completed before we could kill it. Let me execute it again. So we can see this session got killed. So here we can see transport level crash occurred and receiving the results from the server. So as we have killed the session, so this session got killed. So the login with process admin can kill the connections of other users. So I have got this. So here I have got this. So like the number 77 here, I have got 62 here, but that is not the way we find the session information. To get the session information, we use a stored procedure called sp_who to active. So this will give all the active sessions that is running in the instance. There is one more way. Select star from sys processes. So any of this can will let us know. So any of this will provide the active sessions that is currently running in the instance. For example, I'll execute it again. It will take some time anyways. So here we can see this is the select statement that is currently being executed, and the SPID is 67. So same way we can find it from select star from sys processes. So SPID 67. Through sys processes, it will give a lot of information. So it will be difficult to identify the required process. Through sp_who to active, so it gives us only the required information. So all the blocking details, all we can find it here. So as we go through, we'll learn more about it. Now this session is still executing, and now the session ID is changed to 67. So I'll kill it, and it got disconnected. So like this, the login with process admin permission can kill the connections of the users who has highest privileges in the instance as well. Now I have executed this select statement with a sysadmin permission, and the process admin was able to kill the session before it could get completed. So process admin is a critical permission, and it should not be provided to all the users. And one more permission that we can provide is the security admin. So now I have provided security admin, and this login already has process admin and DB creator. So security admin can grant or revoke the permissions to other logins. So through new SQL login, I am going to provision permissions. So I am providing DB creator and process admin. So the user is able to provide, the login is able to provide the permissions to the other login here. And for example, if this login tries to provide a sysadmin permission, it cannot happen because it is the highest permission. So security admin cannot provide the sysadmin permission, but the security admin can provide the other permissions which the login has. So now the new SQL login is a security admin. It has DB creator and process admin permission. So it was able to provide those permissions to other logins. So this is how we provide permissions at instance level. So let's test the database roles now. We have discussed about provisioning the server roles. So let's see how to provide permission at database level. So I'll consider the same login. Go to properties, and I'll revoke all the permissions at server level. And this is the script for this. Alter server role, drop member, new SQL login from DB creator, process admin, and security admin. Now I have revoked the permissions. So now the user is not able to access any database. Now let's provide permissions at database level. So for new SQL login, go to properties. So we provide permissions at server level through server roles. For databases, we have to choose user mapping here. So it will list out all the databases in the instance. So these are all the databases that is available in the instance. So it is all listed here. And here we have to select the required database. For example, if the user wants to have permission at AdventureWorks 2019, so we have to select the database. By default, public permission will be selected. Okay, I'm going to give the public permission. What the user can do with public permission, we will see now. So with public permission, the user will be able to access the database, connect to the database, AdventureWorks 2019. But when the user tries to find any user tables, the user is not able to find. But actually, in AdventureWorks, these are all the tables available, but the user is not able to view the tables because the user has only public permission. Now let's provide some more higher permission to the same login. It is new SQL login. Properties. For databases, we go to user mappings, select the database. Now let's provide data reader permission to the user. Data reader, add member, new SQL login. With data reader permission, the user should be able to view all the tables and read information from all the tables in the database. The user is able to view all the tables here, and the user can read data from the tables as well. You can read data from any of the table under the database. But if the user tries to access other databases, the user cannot access because the user don't have permission on those databases. And we have provided only data reader permission. So if the user tries to edit the data from the database table, so the update permission was denied on the object. So the user doesn't have update permission, the user has only select permission. Okay, let's provide data writer permission. along with data reader. So I have provided data writer permission as well, and I'll try to edit again. So there is some constraints over here. So now here we can see we are able to make modifications with data writer permission. And if the user tries to take the backup of the database, so the backup permission is denied for this user. So the user should have minimum of backup operator permission to take the backup of a database. Let's provide the permission here itself. So the permission is backup operator. So with this permission, the user is able to take the backup of a database now. So like this, we can provide different types of permissions at database level. And if you could see here, so this is connection I have made with sysadmin permissions, and I am able to access all the objects and all the databases under the instance. And this is the connection I made with new SQL login, which has restricted permissions. And here new SQL login is not able to view SQL Server agent at all. So we have to provide permissions to new SQL login to access SQL Server agent. So to access SQL Server agent, the user should have permission on MSDB database. So MSDB is a system database which holds information about the SQL Server agent. To access SQL Server agent, the user should be provided permission on MSDB database. And there are three permissions that can be provided to access SQL Server agent. They are agent user role, agent reader role, and agent operator role. So these are the permissions we can provide to access SQL Server agent, and the permissions has to be provided on MSDB database. So let's see how we can provide. Go to security logins. So the same login I'll choose properties, user mappings, and we have to choose MSDB database here. So these are the three roles: agent user role, reader role, and operator role. So let me provide agent user role. And if you can refresh now, so the user will be able to view the SQL Server agent. With the user role, the user can only connect to the SQL Server agent. But if you try to expand or try to read information, the user cannot access anything. So these are all the information that is available under SQL Server agent. So we have jobs, and there are few jobs all available as well. But with agent user role, so the user is not able to view any jobs under SQL Server agent. User role, the user can only connect to the instance. So the next role is agent reader role. So with agent reader role, the user will be able to view the jobs in the SQL Server agent. So the user is able to view the jobs, and the user will be able to view the history of the jobs as well. So history is the last execution information about the jobs. So the user will be able to view that history information as well. But if the user tries to execute the job, so the job cannot be executed. Only owner of the job or role sysadmin or SQL Server agent operator role can start and stop the job. So agent reader role cannot, like, do not have permission to execute the job. So let's provide agent operator role now, which is the highest permission. And mostly we should not provide the agent operator role to all the users because they may execute the job, and as a database administrators we do not know what is the business logic inside the jobs. So if you provide this permission to some user, they may misuse the permissions by executing the jobs. In some cases, some jobs will have a code to modify data or delete the data as well. So we should never provide agent operator roles to all the users. So now let's see what the agent operator role can do. So the agent operator role will be able to execute the job successfully. Now we can see the job execution got initiated. So these are the permissions that can be provisioned at database level. Let me say take some time. So now we have seen if the permission is provided on database, it is applicable for all the objects under the database. That is, if data reader permission is provided to the user, so if the permission is provided on a database, the permission is applicable for all the objects under the database. For example, we have provided data reader permission. With data reader permission, the user was able to access all the tables under the database. But if you don't want the user to access all the tables, we can restrict the user to only to the required tables. So let's see how to do that. So again, at instance level, we provide permissions to logins through server roles. At database level, we provide permissions to users. So at database level, we provide permissions to users through database roles. Object level, so we provide permissions to securables. So at object level, we call them as securables, and we provide permissions to objects. So the objects can be tables or stored procedures, or it can be views as well. So we provide permissions to the securables at object level. So by providing permission at object level, the permission is only restricted to that particular object. So let's see how to do that. First, okay. So let me go to ADV 2019, and there are a few tables. And if I try to provide permission on only this table, I go to properties of the table, permissions, and here I search for new SQL login. So the user is not available here. So to provide permission at object level, the user should have minimum of a public permission on the database. So first I provide public permission on the database. So through security, logins, new SQL login, properties. So if the user wants to access objects from ADV 2019, I'm just providing public permission. I'm not providing any other permission here. So after providing the public permission, so a user is created under the database. If you could go here, ADV 2019, security, users. So now new SQL login is available. Previously, this user is not available here. After providing public permission, the user is available under security of the database. Now, with public permission, the user can only access the database but not able to view any tables in the database. So now let's provide some permissions on some tables. So go to the properties, permissions, and here we have to search for new SQL login. So now the user will be able to connect here, and these are the permissions we can provide on the table. So we can provide alter permission, control, delete, insert, select, take ownership, and we can deny the permissions if the permission is granted. And with grant is like the user will be able to provide the same permissions to other users. First I am providing select permission only. Grant select on table to this login. So after granting the select permission, so the user is able to view only that particular table here. And as we have provided select permission, the user can perform select operation on the table. And if the user tries to edit, so update permission is denied. Okay, let's provide update permission as well now. Grant update on this table. So here we can see we are able to update the information that is already present. So if the user wants to insert new rows, we have to provide insert permission, and this has to be provided on each table or each object. For example, I will provide a permission on one more table. So we have test login already available. Now again I provide select permission. So the user will be able to access the other table also now. So now the user is provided permission on two tables. So now the user is able to access two tables. So like this we can provide permissions at object level as well. So permission is provided on database level, the user will be able to access all the objects on database. And if you want to restrict the permission to the required objects, we can provide permission at object level, and we provide permissions to the securables at object level. For example, if the user wants access on stored procedures, so for example, we provide execute permission. Go to properties, permissions, so test login. So I'll provide execute permission. So the user will be able to execute it. We no need to provide the permission to the tables, so which the stored procedure is using. So let's see what are the tables the stored procedure is accessing. So this is the actual stored procedure. So it is accessing production.bill materials. So that is one of the table it is going to use. So we have provided execute permissions now. So the user will be able to execute that stored procedure as well. Programmability, stored procedures. Okay, let me just execute it directly. but we may need to pass some parameters. So by just providing execute permission, the user will be able to execute it. So here it is not displaying. Let me see what is the database. It is ADB 2019 itself. Let me make a connection with this login. So the user is able to view this and execute the stored procedure. I'm just passing some null values. So stored procedure is executed even though the user doesn't have permission on the underlying tables. So, and also like we can create database roles. Apart from the predefined roles, we can create a new database roles as well. For example, on this database, under security, we have some built-in database roles. And if I want to create a new role, I can create like this new database role. I'm calling it as select. So it is select table. And if you go to securables, we can choose all the objects of the types. And here we can choose the tables or any other objects. I'm choosing tables here. So I'm going to provide select permission only on few tables. And if you assign this role to the user, so the user will be able to access only these tables. Security logins. So for new SQL login on ADB 2019, so we can see the user can be provided select table permission. So here we can see the user is able to view like access only those tables. So like this, we can create a user-defined database role as well. Apart from the predefined database role that is available, we can create a database role as per our specifications and requirements, and we can assign those roles to the users. And the security admin at database level will be able to create new roles also. So that is why it is treated as a critical permission. So we have seen how to restrict the permissions till object level, that is at table levels also. So let's assume this is a Windows server, and we have install SQL Server in it. And this instance will have databases, logins, jobs, and application will be connecting to this instance, and they'll be accessing the databases from this instance. So what will happen if any of the database is offline? So it is a single point of failure. So even though we have taken the backups and we'll be able to restore it back again, So it will be downtime for the application till the time we restore it back completely. So till the time we restore it back completely and application make a connection with that database. So it is a downtime for the application. So most of the applications, they are business critical applications and they cannot afford a highest downtime. So to avoid all those things, we have different availability concepts in SQL Server. So with the availability concepts, we can maintain the copy of the databases or the tables or complete services in a different server. And if the primary copy is not available, we can make applications connect to the secondary copy immediately. So with very minimum downtime, we are bringing up the services and we are ensuring the database availability. So what we'll do is we have to set up another server also for availability. So this will be another Windows server. This would be another virtual machine, and we have to install SQL Server in it. So this is a different instance of SQL Server, and we'll maintain the copy of the databases in this server. But it will have a different logins, different jobs also, and it can have additional databases as well. Apart from these databases, it can have some other databases also. So it can have DB3 as well. So now the data has to be transferred continuously from SQL instance 1 to SQL instance 2. So that means there should be communication between these two servers. For these two servers to communicate, these two servers should be part of the same domain. So these two servers should be part of the same domain, then only the data can be transferred or the communication can happen from one server to another server. So now we need to set up an environment for two, like with two virtual machines, each one for different instance of SQL Server, and also we should have one more virtual machine which is a domain controller. So totally we require at least 3 virtual machines. So in domain controller server we configure DNS services. So by using DNS services, so we'll make these two servers part of the same domain. So let's see how to do that in a Azure environment now. So usually this setup will be performed like configured to us by Windows administrator team. So here we have to perform like we have to configure the environment to work on availability concepts. So here we need to create at least 3 virtual machines, and so the setup will be different compared to the previous one we have done. When we first install the virtual machine, we need to follow almost same steps except a few more additional steps we need to include here. Parallelly, we can create a new virtual machine. So first we need to create one virtual machine for a domain controller server, and all the servers has to be part of the same resource group. I'll call this server as a new domain, and all the servers has to be part of a same region. So in case of a free subscription, so the restriction is we have to use them in the same region. So if it is a paid subscription, we can have the servers in any of the region. I'll choose West US, and availability options, we can create a new availability set. And image is Windows Server 2019 itself. And size, as this is a domain controller server, I'll just use 1 CPU and 2 GB of memory, and we have to provide administrator user ID and password. And we have to select the ports that needs to connect. So next is disks, nothing needs to be selected here. And next is networking. So here we have one important step. So it should be all part of the same network security group. So we'll choose advanced, and security group new domain -nsg is getting created here. So the other two servers also should be part of the same network security group. And apart from this, the rest of all options, you can just give next and get our virtual machine created. So this is a normal virtual machine only. We have to make it as a domain controller. Once it is created, we can make it as a domain controller. The deployment would take some time. So we are creating this domain controller server now. So after that, we have to create two more virtual machines, each one for one SQL instance. And we have to install SQL instance separately on both the nodes, on both the servers. The deployment is still in progress. The deployment seems to be completed. Still it is showing us in progress. So let's try to connect to the server now. So we are connected to the server now, and this is a normal server as of now. Now we have to make this as a domain controller. To make it as a domain controller, we have to connect to the server manager. So it gets connected by default. So in the server manager, manage, add roles and features. So it is still getting, and we have to install the server role. So we have to come to the server roles, and Active Directory domain services is checked. And we can click on install to get it installed. It will take some time. This server role, Active Directory domain services server role will be installed. And after that, we have to make this as a domain controller. So a few more steps needs to be followed after this installation as well. The installation is completed. We can close this, and here we can see message. So we have to promote the server to domain controller. Now we have just installed the services, but we have to promote this to a domain controller. So we click on it and click on add a new forest, and we have to give name for this. I'll give it as westdomain.com, and we have to provide password. Click on next, and this will be the NetBIOS name. We can change the name if required. We can just use it. Whenever we are connecting to the server next time, we have to prefix the login with this domain name, that is West domain. So this is quite time taking process. Each step would take some time here. So the server was successfully configured as a domain controller, and for all the changes to get installed successfully, we have to restart the server. Now we'll create two more servers for installing of SQL Server instances. As I told, we have to use the same resource group, and we have to give name for the servers. I'll call it as DB1, and they have to be from the same region only. So availability option is not required. We install Windows 2019. And we'll use 1 CPU and 2 GB of memory. This is administrator user ID and password to log into the server. We have to provide password. We have to select the ports to connect. License for Windows, we need to select. Next is disks. So nothing needs to select here. Networking. So here it is an important step. So we choose network security group as advanced. And here we can see westdb1-nsg is created. But all the servers should be part of the same network security group, that is new domain-nsg. So then only we'll be adding the servers to the domain. So if not, we cannot add the server to the domain. So we want create and we can get it created. So this will take some time for creating. And we have made the server as a domain controller. Let's connect to it. So here we have to use more choices this time. And the domain name is West Domain. And this will take some time for loading all the changes, all the policies it needs to upload for a domain controller, and it will take some time for loading all these things. So let's check the progress of the other virtual machine we are creating. The deployment is still in progress. So deployment is successful. We can connect to the resource. So this is this is not yet part of a domain now. We have to add this server part of a domain. A few changes we need to make here in the server to make this part of the domain. So here also we need to connect to the server manager, local server, Ethernet settings. Go to the properties here and IPv4 settings and properties. And we have to use the following IP address. So to fill up the details here, we go to command prompt, ipconfig. So these details we are going to fill it here. It is 10.035, 255, 255 and 255 is the subnet mask, and default gateway is 10.031. So these are the details we are going to fill it here. So 10.031 is the default gateway, and here we have to give the IP address of the domain controller server. So it is 10.034. I'll show you whether it is at 10.034 or not. Click on OK and close. Server will be disconnected for a moment and it will connect back again. It is disconnected and it will connect back again. It is connected. So we no need to close those connections. We can just wait. Now I'll disable the firewall settings just to ensure firewall is not blocking the server from being added to the domain controller. So here it is in work group now. We have to click on work group. We have to click on work group, change, and domain. We have to give it as westdomain.com. So this is the name of our domain. Domain. We have to give the user ID and password. So welcome to westdomain.com. That is, our server is successfully added to West Domain. And for the changes to take effect, we have to restart it. So same way, we have to create one more server as well. So let's create one more server. It is So same steps, SQL DB group. So it should be part of a same resource group. So I will call this as WestDB2. And this also has to be from the same region, West US. And I'll use Windows Server 2019. And I'll use 2 CPUs and 4 GB of memory. So in one region, we can have maximum of 4 CPUs for this free subscription. So in case of paid subscription, we can use any number of CPUs. The limitation with free subscription, we can use 4 CPUs per region. So we have used 1 CPU each for the other 2 servers. So 2 CPUs are left over. I'm using 2 CPUs for this virtual machine. Hello, select the ports, license. Nothing needs to be selected at disk. And again, in networking, we have to choose advanced and we have to choose new domain -ns. The rest we can just click on next, review and create. So the deployment has got initialized and it would take some time. By the time, let's try to log in to the WestDB1 server, which is added to the domain. So it would have got restarted by this time. More choices. So here we have to give the domain name to connect. West domain and the administrator user ID and password. And here we can see in the local server. So previously it was work group. Now it is added to the domain westdomain.com. So the server is part of a domain now. So we have to add the other virtual machine also to be part of a domain. So the same steps. We have to connect normally to the server first through RDP. We have to connect to the server manager. The local server and Ethernet settings we have to change here. Properties, IPv4 properties. IP config, it is 10.0.36. And 10.0.34 is the IP address of our domain controller server. Next, I'll disable the firewall. And we have to give it as westdomain.com. The server is also part of a domain. So now we have to install SQL Server the same way we have installed during our initial classes. So we have to install SQL Server on both the servers, that is on WestDB1 and WestDB2. And then we'll be using these two servers for our availability concepts. So now the setup is completed. Now let's see. Let's start introduction of one of the high availability concept called log shipping. Log shipping is an high availability concept at the database level. So we are going to maintain the another copy of a database in a different location. So basically, log shipping is an automated process of backup and restore. So usually we take the backup, and whenever there is any issues, we restore them back using the backups. But in log shipping, we are continuously going to take the backup of one database and restore it onto the another database in a different instance. So thereby, all the transactions in one server is transferred to the another server also. So let's see what is log shipping. So log shipping is an automated process of a transaction log backup and restoration. So the backup is taken from a first server and it is restored on the second server continuously through SQL Server agent jobs. And the primary purpose of log shipping is to maintain the high availability, that is to ensure availability of a database. So if in case a primary copy is not available, so we'll be able to connect to the secondary copy immediately. And this log shipping is achieved in 3 steps. So we take the backup from a primary server and we copy the backup file from primary server to the secondary server and restore the log backup onto the secondary server. So let me show you how it works. So let's assume this as SQL instance 1. So we have Windows Server and we have SQL Server instance installed. So I'll have one database in this instance, it is DB1. And also I'll set up one more server. I'll call this as Win Server 2 and I'll install one more instance of SQL Server. That is SQL instance 2. And we'll have the same copy of a database. I'll show how to configure this as well. So we'll have the same copy of database. Now, if any transactions are performed on this database, it has to be transferred to this database also. So to ensure we have the same data in both the databases, but they are in a different instances. So to achieve this, we configure log shipping. And whenever we configure log shipping, 3 jobs will be created. One is a backup job. So this is created in the primary server. So it takes the backup of transaction log backup of this database and places the backup file in a shared folder. So we have to create a shared folder also. I'll show you how to create a shared folder. And this has to be shared folder because so here 2 more jobs are created. Copy job and restore job. So this copies the backup file from this shared folder and places it in a local folder here. And this is the restore job. So the backup job takes the transaction log backup of this database and places it in a shared folder. And copy job from another instance copies the backup file and places it in the local folder. And the restore job uses this backup file and restores it onto the DB1. So this all will get executed as per the schedule. So we'll be setting up schedules for each job for backup, copy, and restore job. And this will ensure the data is transferred from one server to another server onto the same databases. So this is how the log shipping would work, but we have to learn about a few prerequisites that we need to do for setting up log shipping. Let's start this session now. So next thing is monitoring and tuning of SQL Server. And there are different monitoring tools available in SQL Server to monitor the performance of the server. And before we jump into the tools that are available, let's see what needs to be monitored. So to know what needs to be monitored, before that we have to know how the SQL Server is built up. So for this we have to know about the prerequisites of SQL Server and the architecture of SQL Server. To install SQL Server, so we require software and hardware prerequisites. So coming to the hardware prerequisites, we require a CPU and certain amount of memory, that is RAM, and we need to store the data, so we require a storage. And for applications to connect to the SQL Server, we require network. So based on these things, we have installed the SQL Server. For each version, there may be different prerequisites, but basically, so these are the components required for installation of SQL Server. So these are all the things that needs to be monitored, and we call it as resources. The resource utilization has to be monitored. And coming to the architecture of SQL Server, so we use the architecture of SQL Server to determine the query performance. So the basic objective of SQL Server is to store and retrieve data. So we store and retrieve data by using T-SQL statements, and we call this as query. So we store and retrieve data in the tables in the form of rows and columns. And we query the we store and retrieve data by using a T-SQL statements, and we call them as queries. And for every query plan is created by the optimizer. So optimizer uses the statistics information to create a better query plans. And these T-SQL statements works based on the ACID properties. So I'm giving the overall picture like what needs to be monitored and why we need to monitor the things. This T-SQL statements gets executed in SQL Server based on the ACID properties, because so these are the properties of a transaction in our DBMS. So every transaction should satisfy this property to be a proper statement or a proper transaction in a RDBMS system. So these are all the factors that impacts the performance of SQL Server. So basically, to monitor the performance of SQL Server, we have to monitor the resource utilization, and next thing is we have to monitor the query performance. So there are different ways to monitor the resource utilization and to determine the issues, and in the same way there are different ways of improving the query performance. So to improve the query performance, we have to create indexes on the tables, and we have to maintain the statistics up to date, and we have to ensure that there is less blockings and deadlocks occurring. So these are the things that we need to monitor for the optimal performance of the SQL Server. So this is the outline I am giving. So we have to go deep into each topic. So let's start with resource utilization. So whenever we are reported that SQL Server is running low, so the first thing we have to check for is the resource utilization in that particular host. So we have installed SQL Server in one of the Windows host, and we have to check the overall resource utilization of the host first. So to check the resource utilization in the host, we go to Task Manager, and here we can find the CPU and memory utilization of all the processes that is running in that host. So SQL Server is also one of the process running. We have to find the resource utilization of SQL Server. So we have two instances, and this is the resource utilization by each instance. So if it is MS SQL Server, it is the default instance, and if there is any other name, it is the named instance. So the default instance is utilizing around 656 MB of memory, and there is no CPU utilization as of now because there is no transactions happening in that host, in that instance. So the CPU utilization may vary depending on background process running also. So this is the first place where we can check for the overall utilization of resources in the host. And here we can find whether SQL Server is a process that is consuming more resources, or we can check for any other process apart from SQL Server that is consuming more resources. So we have to check in the task manager to determine the process consuming more resources in the host. So if it is SQL Server that is consuming more resources, we have to connect to the SQL Server and find the processes consuming resources in SQL Server. So we need to connect to the SQL Server, and in the SQL Server we have a tool called Activity Monitor. So this Activity Monitor gives the details about all the processes that is currently running in this instance. And also if there is any weights, the resource weights will be displayed here. So it takes some time to load the data. Input output on the data files will be displayed, and expensive queries based on the resource utilization. It will display the recent and active expensive queries as well. And apart from this, we have one more mechanism called reports. So we can find the resource utilization through reports as well. So to go to the reports, I click on the instance, reports, standard reports, and we have to check for the queries that is consuming average CPU, total input output, or average input output. So this will display the top queries that is consuming more CPU and more input output. So you can just click on it, it will provide us a report. I'm connected with a different user who don't have enough permissions. That is the reason I was not able to see the process all this information. Let me connect with a complete permission. So we can view the activity monitor also now. So this will display all the processes that is running in the SQL Server. So this is displaying the session ID above 51. So session ID 1 to 50 is allocated for internal processes only. So no user process can take up the session ID below 50. And what is the login using the process, on which database it is using the process, from which application the process is being utilized also it is displaying here. So here we can see mostly it is from SQL Server Management Studio. as we are executing the queries from Management Studio. If it is any other external application, the information of the application also will be displayed here. So this displays all the process that is currently running in the SQL Server. And here we have to find out recent expensive queries. So the queries that has consumed more resources in the last recent executions. And here we can find the execution count, how many times the query got executed, and maximum CPU and input output it has utilized. So it is not giving a clear picture, and this will give the active expensive queries. So there is no active expensive queries running as of now. So we can get the same information with more clarity through reports, standard reports, and here we can find few reports which I have already used. It is listed out here. And if I want to generate a different reports, I go to standard reports and tab queries by total CPU time. So this will display the top 10 queries that is consuming more CPU, and the time CPU, the time this query has utilized the CPU in milliseconds, we can find it here. So these are the queries that is consuming more CPU in the instance. So as there is no much process happening in the SQL Server, it is all the internal queries that is being displayed. So if user transactions are happening more, so if there is more user transactions happening, so it will display the user transactions that is consuming more CPUs here. And in the same way, we can also find out the queries that is consuming more, that is causing more input output in the server. So same way we can go to standard reports and top queries that is consuming more input output. So here is the query text for that, and total logical input output reads it has performed. So this is also mostly the internal process. And we can also find out the memory consumption reports, and as I have already used, it is listed out here, memory consumption. The number of dirty pages that is there in the buffer manager, we can find it here. So on execution of a checkpoint process, all these dirty pages will be flushed to the disk. And memory usage by components. So these are different components that is running in the SQL Server, and that is consuming this memory allocated to the SQL Server. So other than the reports, we can use DMVs as well. So DMVs are the dynamic management views, which gives a comprehensive information about the performance of SQL Server. To find the details of active transactions, we have different DMVs. Let's see that now. So we have DMVs like sys.em query stats. So this query stats will give the information about the resource utilization by the top queries. And we are using additional DMVs like SQL text and query plan to find the plan of that particular query and what is the SQL text that was implemented as part of that query. So these are the top 10 transactions, top 10 queries that is consuming more CPU time. So this is the amount of CPU time this queries has utilized, and we can find the query plan of those queries as well. So query plan is a step-by-step process of executing a query. So it is doing select statement is being performed, and it is working on table valued function and filtering the rows and joining the results and sending it as a select statement result. So this will give the top 10 CPU consuming queries. So if you find any user queries that is causing more CPU, we can notify them. So if it is taking up all the available CPU, so it may impact the performance of other queries. So in that case, we have to find the query that is consuming more CPU time, and we can notify to the owner of that particular query or the application from which it is executed, and based on their instructions, we can just let it to leave complete, or we can kill the session. So it depends on the decision taken by the application team. But it is a database administrator who implements it, whether to leave the session to get completed or to kill the session. And average consuming queries. So this will give the execution count as well as on an average how much CPU is being consumed by the particular query. It can be displayed by using the same DMS itself, but we are doing some calculations here. So total work per time by the execution count. So here is the execution count, worker time, and on an average for each execution, this query is taking this much time of the CPU. And also we can find input output intensive queries. The queries that is causing more input output on the SQL Server, we can find by almost using the same DMS itself. So here also we are using exec query stats, but we are using a different columns here. It is going to display us total reads a particular transaction is performing, number of writes. If there is any modification, we will get it under total logical writes. Execution count, so how many times the query was executed, and total input output it has consumed for all the executions. So sometimes some queries may be causing more input output. By using these DMVs, we can find out the queries that is causing more input output in the server. And overall expensive queries we can find by using the script. So the scripts can be used, we can keep it handy, and it can be very helpful in our daily day-to-day activities. So still, if you are able to write a query also, immediately it would take some time to find out, to list out what are the information we require from this particular session. So rather than that, we can use this script handy, and it will provide us a comprehensive information. So it is giving the top 10 queries, its execution count, so the logical reads, logical writes, and total CPU time it has consumed. So based on that, what are the top expensive queries it has displayed us, and we can view the query plan of these queries under query. So these are the tasks that are being performed to complete this query. So if you want to understand the query, we have to read it from right to left. So it has to start from right to left and bottom to top. This query is performing index seek operation, index scan operations. So it is doing index scan. So it is performing all these operations for implementing the query. So it is the step-by-step process of implementing the query. And here we are having a look at the costliest queries that is running in the SQL Server instance. So we have seen the queries that is consuming more CPU and more input output, but also we have to find out the memory utilization also. Memory utilization is also one of the major component that affects the performance of SQL Server. So if no much memory is available for SQL Server, so any transactions performed on the SQL Server will become slow, because it has to read the copy of pages from disk to buffer manager and read the data from there. And if there is no arrow space, it has to wait till the previous pages, that is 30 pages, are flushed to disk. So we have to maintain optimal memory for the better performance of SQL Server. So usually the memory should be allocated in such a way that SQL Server is restricted to use 75 to 80% of the total server memory. So if you don't restrict the memory utilization of SQL Server, as per the behavior of SQL Server, it can consume all the memory available, and it can make the OS also to hang up. So we have to restrict the SQL Server memory utilization 75 to 80% of the total server memory. And this allocated memory, what are the components that is consuming more memory, we have to find out. So for that also we have a DMV. So we can find the memory utilization details by using sys.dm OS buffer descriptors. So this query will give us the information about the memory utilization by each database in the instance. So how much memory is being utilized by each database, we can find it here. So the top in the list is StemDB, because StemDB is used by all the users and all the databases. Most of the cases StemDB will be on the initial parts. And coming to the system databases, user databases, we have AdventureWorks in the top of the list with this many pages in the buffer, and the size it has consumed is 34 MB, and percentage it has consumed 23% of the total memory that is available for SQL Server. And inside this database, what are the components, so which table information is stored in the memory, we can also find that also by using memory utilization inside DB by objects. So if there is any fluctuations in any of these resource utilization, it impacts the overall performance of the SQL Server. So if CPU is being utilized more, or memory is less, or more input output is happening, so these things are all interdependent. So if there is problem with one thing, it will impact the performance of other things as well. For example, if we have a low memory in our SQL Server instance, low memory is allocated, so there should be more input output will be happening. I'm going to show you how each thing is interdependent. So let's assume we have SQL Server and we have some resources allocated to it, some memory, and input output will be performed from this, and we have CPU. So around 4 GB of memory we have, and this is the CPU. So if this almost this 4 GB is utilized, so whenever a transaction is performed, so the transaction, that is the access methods, will try to find the pages that is already available in the memory or not. If the page is not available, it will get the copy of the pages from disk to the memory. So with low memory, so it has to flush out the old pages and copy the new pages very frequently. This will cause more input output. So as more like for most of the time it is copying the pages from data file to the memory, so it has to consume more CPU. So CPU utilization will become higher in the instance if more input outputs are happening. So here, due to lack of like low availability of memory, so it is impacting the input output performance as well as the CPU utilization as well. So here everything is interdependent, and we have to maintain all the components in an optimal way for the better performance. So here we were discussing about inside the database, what are the components, like what are the objects that is utilizing more memory. So we have got this here. So here we can see a user table. It is having a clustered index, and it has 814 pages in the buffer, that is in the memory. That means this table is very frequently being utilized. So as the table is frequently being utilized, the pages of this table is still exist in the memory. So as more such operations happen, so the copy of multiple tables needs to be maintained in the memory. And if there is no memory space, the transactions that is trying to copy the pages to the buffer manager, it will get hung up. Or SQL Server has to constantly flush out the dirty pages from buffer manager to disk. So it is also a resource intensive operation again. So we have to optimally maintain and utilize the resources. So I'll get few expensive queries. I'll create a few expensive queries, and let's see how it impacts the performance of the overall server and how to troubleshoot it as well. So this query also will provide us the costliest queries that is consuming high CPU. And in most of the cases, it is the stored procedures that can cause high CPU also. So we can find out the stored procedures that is consuming more resources. So we could see there is no stored procedures executed as of now. Let's execute few stored procedures from AdventureWorks 2008. So we find stored procedure information under programmability of the database, and we have stored procedures. Let's execute few stored procedures by passing some null values. So we are able to find the details of the stored procedures now. So in an real-time environment, there will be many stored procedures being executed to perform different types of tasks. And there is possibility of stored procedures consuming the resources. So we can find out the stored procedure that is causing more resource utilization, and we can notify it to the development team to fine tune it so that on every execution it consumes less resources. So till now we tried to find out the resource utilization, and we were able to find out the queries, find out the expensive queries. So what needs to be done on finding out the expensive queries? So we have to notify it to the application team or the development team that particular transactions are consuming more resources. And there are different reasons the transactions would consume more resources. So we have to find out that as well. So for example, if I have find out one of the query that is consuming more CPU, so we have to look into the design of the query, so how it is designed, and plan of the query, how it is being executed. So the design of the query is like if it is very much big query that is containing of more joins and more subqueries, so it will be a complex design for the query. And for implementing the complex query, so the plan also will be on the costlier side. So SQL Server has to utilize more resources to complete the query. So we have to find out how we can design the query in a better way, and what are the components, like what are the factors that is causing the costliest query plan. So we have to look into the query plan and see how the query plan is being implemented, and we have to find out the components, or we can put it like this: costlier components. in the query plan. So based on these things, we can give suggestions to the application team to fine tune the query. So it is not the database administrator who fine tunes the query. We have to do our findings and provide our suggestions to the application team. And in some cases, so the application team will notify us they cannot design a query better than this, and they cannot make the query to choose a better query plan. So in that cases, we can restrict the resource utilization for particular applications or users. So there will be environments that will be used by multiple applications and multiple users. And some application can consume more of the resources. And so in some cases, some users can consume more of the resources. So in these cases, if you notify them and if they come up with a reply that they cannot make it much more better, so we have a option to restrict the resource utilization for a particular application or a user. And for this, we have a tool called Resource Governor. By using this tool, by enabling the Resource Governor tool, we can restrict the CPU, memory, and input-output of the IOPS of the application or the user. So you have to still go deep into these things. I'm just providing the steps that we are going to perform. So we'll find the resource governor under management in the SQL Server. Management and resource governor. So by default, the resource governor will be in a disabled state. We have to enable it. So here I have already used the resource governor. So let me drop all these things. So I have already implemented resource governor in this instance. I'm just dropping off all the things. These are the resource pools. And we have workload groups here. So to re-implement it again, I'm going to drop the existing setup. Let's try to drop these workload groups. And I'm disabling the resource governor as well. And by default, this will be the state of the resource governor. It will be in a disabled state, and we have to enable it back again by clicking on enable. So this resource governor got enabled now. So by default, if you don't use the resource, enable the resource governor. So let's see how the SQL Server would work. So SQL Server will be receiving connections from different sources. So it can be from internal processes. It can be from an internal process or from SSMS or a report server or it can be from any other external applications. So SQL Server will be receiving the connections from different processes. So by default, there will be two resource pools. Even though we enable a resource governor or not, there will be two resource pools. One is internal resource pool, the other one is default resource pool. So in the resources that is allocated to the SQL Server, a certain part of resources is grouped and it is just it is separated and it will be allowed to use only by the internal process. So for the execution of SQL Server, so some internal resources, some resources are put aside and it will be used only by the internal process. So no other process, no other user process can use the resources from this internal resource pool. And all other process will be consuming resources from the default resource pool. So this internal process, it will be separate only all the time. So if any internal process gets initiated, it consumes the resources from this resource pool only. And if there is any user process, they'll be consuming the resources from the default pool. So let's assume in this default pool, so we have 4 GB of RAM and 8 CPUs, and there will be some in IOPS also will be available. So from this default resource pool, if SSMS itself is causing more, like it is consuming more resources, so it will make the report server or external applications to starve for the resource. So in this case, we can restrict the resource utilization of SSMS by creating an additional resource pool. For example, here I will create one more resource pool. So these are called the user resource pools. I will call this as user pool 1, and I'll restrict the resource utilization in this pool. So by maximum, it cannot use more than 30% of the resources. So in this available memory, CPU and IOPS, it should not use maximum more than 30%. And now any incoming connections from SSMS will utilize the resources from this pool. So how SQL Server can determine the connections is from this SSMS or from any other application. So we have to create a classifier function for that. So we'll create a classifier function which classifies the incoming connections based on an application name or a username and redirects the connections to the required pools. So rather than moving like making utilizing the resources all from the default pool, so it will classify the incoming connections, and based on the classifier function, it will redirect the connections to the required pools. So if the connections, all the connections is from SSMS, so the classifier function will classify that the connections is from SSMS, and it redirects all the connections to user pool where it cannot utilize more than 30% of the available resources. So if it is reaching 30%, the transactions from SSMS will not work. So this will be used in case of a multi-user environment where few users will be consuming more resources.